Right, for this question we're looking at functions. So a ball is thrown into the air, so we're looking at the practical application of it. The formula y equals 20x minus 4x squared. So a couple of things here. Remember now it says y equals 20x minus 4x squared. That could be presented as f of x equals 20x minus 4x squared. They're the same thing. We can also see that it's an x squared. Okay, so do you know what type of function that is? Okay, it'll be a quadratic. And if we look a little closer, we can see it's minus 4x squared. Okay, which you expect to give a U shape. So the relationship between y shows its height, y, above the ground in meters, and x seconds. So we can go to our graph and we see that this is time and this is height, the y-axis and the x-axis. Okay, this is the x-axis and here is the y-axis. So I'm going to come back to that graph in a minute. Copy and complete the table of values is part 1 here to show the height of the ball for its first 5 seconds. So you could do this manually by substitution. So you'd have for x equal 2, they have 0 and 1 done for you. You'd have y equals 20 times 2 instead of x. Minus 4 times 2 squared. Okay, you will get 20 times 2 is 40, 2 squared is 4, 4 fours are 16, 40 minus 16 is 24. So 24 will go in here. Okay, the table is probably a little bit too small to write in the calculations. Alternatively, and what's probably better, is to use the function calculator. Leaves less room for error. So on your calculator, the function option. So 3 seconds is 24, 4 seconds is 16, and 5 seconds is 0 again. So let's move to our graph. Okay, we can see 0 seconds is 0 meters. Now that ball is thrown in the air. So after 1 second it's 16, which is about here. 2 seconds it's 24, which is just under 25, about here. Here is the highest point of the ball. Okay, 3 seconds is 24, so it's the same on the other side. 4 seconds will be 16, it's the same on the other side, and 5 seconds the ball is back on the ground. Okay, so there's our graph, which they ask you to do in part 2. So it's important to label the axis. For me, it's going up in 5s. It'd probably be more accurate if it was going up in 2s or even 1s. And the x-axis should definitely go over in 1s. Time in seconds. So part 3 asks us a couple of questions. The maximum height reached by the ball. Okay, so the maximum height reached by the ball is here. Okay, it's between 25 and 30, and it's closer to 25. So the maximum height is approximately 27 meters. Max equals 27 meters. And it's important to mark that on your graph to show where you got your answer. At least if your graph is a little out, they know where the answer came from. Okay, and you get most of the answers, or most of the marks. So that's part A. Part B. 2 times when the ball is 12 meters above the ground. Okay, let's use So there's 10 meters, 11 meters, 12 meters. It's approximately here. Okay, and I'm just going to write that, 12 meters. So to find that, we're going to have to plot down to the times. Here and here. Okay, again, we could definitely do with a better graph. So after 0, we go back in here, look at our table. After 0 seconds, the ball is 0 meters. And by 1 second, it was 16 meters. So it has to be before 1 second. I think it's fair to say 0.75 seconds. And we know also that it's after 4 seconds. And it's going to be before 5 seconds. Okay, so I think maybe 4.5 is reasonable. 4.5 seconds. Okay, a better graph will give you better answers, but at least I have them marked on the graph to back up what I'm doing. Okay, sorry for scribbling that out. And part C, the interval of time when the ball is above 15 meters. Okay, we'll do orange for this one, above 15 meters. So that's everywhere from here to here. Okay, we know that after 1 second, the ball is 16 meters, and after 4 seconds, it's 16 meters. So just before 1 second, so let's say 0.9 seconds, 2, and it's going to be just after 4 seconds, 4.1 seconds. And again, the key to this is to mark it on the graph. And the key to that is to draw a good graph, which I don't have using GeoGebra here, because if I zoomed in closer, you wouldn't be able to see the whole graph.